Okay, this video accompanies the SSS and SAS triangle congruence theorems guided notes for section 4.3, and let's take a look at this. So first off, if look at these two triangles, if two triangles are congruent, then their corresponding parts are congruent. So if we have the triangle ABC is congruent to triangle DEF, then because of this triangle congruence, all of their corresponding parts are congruent, which means that angle A is congruent to D, B is congruent to E, C is congruent to F, segment AB is congruent to segment DE, segment BC is congruent to segment EF, and segment AC is congruent to segment DF. So if two triangles are congruent, then their three angles that correspond are congruent, and their three corresponding sides have to be congruent. So there's actually 6 congruence relationships that are given by the order of the congruence statement. You should be able to match them up. If not, the congruence statement is incorrect. A goes with D, B goes with E, C goes with F, AB segment goes with DE segment, BC segment goes with EF segment, and AC segment goes with DF segment. So the order really matters when you're naming a congruence statement. So we have what we call congruent shortcuts. If we can come up with certain combinations of 3 sides and angles that are congruent between 2 triangles, then that's enough for us to know that all the parts of the triangles are congruent. So the first 2 of these that we're going to focus on in this section are the side-side-side triangle congruent shortcut and the side-angle-side congruent shortcut. So let's look at this first one on the left here. So this is our side-side-side congruence triangle here. Notice that we have triangle ABC and triangle. Now we need to name these in order. Okay, so they're saying triangle ABC is congruent to triangle DEF. So from this congruent statement, I should be able to label the congruent angles. Angle A is labeled as congruent to D. So angle A is congruent to angle D. I'll put a matching mark there. Angle B is congruent to angle E. Angle B is congruent to angle E. And angle C is congruent to angle F. So C is congruent to angle F. So notice that they already have marked the 3 sides that are congruent. Side ED must go with BA. So BA has 1 mark and ED has 1 mark. BC, which is these 2, goes with EF, which are those 2. BC has 2 marks, EF has 2 marks. AC has 3 marks, and that matches with DF, which also has 3 marks. So the correct writing of the congruent statement in order has the congruent parts of the triangle, so we can dig those out. Now it turns out that if we can show that 3 sides match between 2 different triangles, that's enough for us to know that the triangles are congruent, which means that all of their parts are congruent. So not only are the sides congruent by SSS, the triangles are congruent. Which means that their corresponding angles and their corresponding sides are all congruent to each other. Now the other shortcut that we're introducing is the side-angle-side congruent shortcut. So if you have 2 sides and an included angle that are congruent between 2 triangles, then that's enough for us to know that all the parts of the triangles must be congruent. So let me mark those. So let's see. So angle S is congruent to angle Y. SR side is congruent to XY side. And ST side is congruent to YZ side. So here we have side, angle, side, side, angle, side patterns. Notice that both of these patterns, in order, as we read around, go SAS. If this triangle had a different pattern than SAS, like SSA, or something like that, they would not be congruent by SAS. But the SAS pattern needs to be seen in both triangles, and that's enough for us to say that all of these parts of the triangles are congruent. So let's say I wanted to name this left-hand triangle RST. So I want to say triangle RST is congruent to the other triangle by SAS. And we need to think about how we would name this other triangle. So let's see. So R to S goes along the 2 marked side to the 1 marked angle. So along the 2 marked side to the 1 marked angle, we have XY. So XY would have to go first to match the RS. And then S to T goes along the 1 marked side away from the marked angle. So Y to Z goes along the 1 marked side from the marked angle. So Z would have to be the correct order to name it in. Let's say I decided to name this triangle, this first triangle, TSR. Well, let's do a different one. Let's do TRS. So if I want to start with TRS, okay, we're going from T to R now, which is along the unmarked side. So and it's at the end of the single marked side. So at the end of the single marked side, we have Z. We're going along the unmarked side to X. So we got Z to X. So T to R is the same thing as going from Z to X. And then X to Y goes along the 2 marked side to the marked angle. And Z to X. And X to Y goes along the 2 marked side to the single marked angle. So Y would have to be the letter there. So notice that T goes with Z, T goes with Z, R goes with X, R goes with X, and S goes with Y. Angle S goes with angle Y. So we can use a certain set of 3 sides and angles in a certain combination to say that 2 triangles are congruent, which means that all their parts are going to be congruent. But we have to be careful when we name the congruent statement, because whichever way we start naming the first triangle, the second triangle's vertices have to be in the same correct corresponding order as the matching vertices in the first triangle. Otherwise, it's not a correct congruence statement. Okay, so let's look at some examples. So this word included in the vocabulary means it's like a hinge between the 2 sides. That's the included side. So 2 sides and the included angle is what makes up the SAS pattern. So just because there's 2 S's and an A in a relationship doesn't actually mean that there's an SAS pattern. It has to be the 2 sides and the included angle. The other 2 sides and the included angle for it to be SAS. For SSS, all 3 sides need to match between 2 triangles. And again, the order that we name it in matters. So let's look here. Let's look at number 1. In number 1, we should be able to see that with vertical angles, this angle KLJ is congruent to angle HLG by vertical angles. And that gives us, if we match up the pattern here, we've got an S with that single mark side. Let me change colors up. We get an S with the single mark side, goes with the other single mark side. We have these two vertical angles that are congruent to each other. And then we have this KL double mark side as congruent to the HL double mark side. That gives us another S part of the pattern. So if we look along one triangle, we have SAS. And if we look at the other triangle, we also have SAS. So these two triangles are congruent by SAS. So we want to write the congruent statement that goes with this. Let's see, we want to do triangle GHL is congruent to triangle. So G to H, we're going from G along the unmarked side to H, and then we're going to head along the 2 marked side. So we're going to go from J to K, which leaves us going along the 2 marked side to get the next vertices. So we got to go JK and then to L. So L matches with L, K matches with H, and J matches with G. Let's look at number 2. Number 2, we've got a side that's shared. This is a common pattern. We've got a side that's shared between 2 different triangles. So we could call this same side. Or we could say that segment PR is congruent to itself. PR is congruent to PR by reflexive property of congruence. So either one of these good reasons would be good reasons for this. And so we can say that that PR side is congruent between both triangles. It's on the left-hand triangle and it's also in the right-hand triangle. So here we have 3 sides. We got S, S, S. So the SSS pattern is going to let us say that these 2 triangles are congruent. And let's see, I want to go PRN, triangle PRN. Oh, I did R. Let's do triangle RNP is congruent to triangle. So we're going from R to N to P. For the other triangle, we have to go R to Q to P. Now, if I did do, say, PRN as a way of naming the triangles, P to R to N, then I would have to go P to R to Q with the other triangle. But notice that Q goes with N up here, Q goes with N, R goes with R, R goes with R, P goes with P, P goes with P. So the matching vertices need to be in the same relative position when you name the congruence. And there's, there are other orders that we could actually name these in also. We could do PNR, we could do QRP, RPQ. There's 6 different combinations that we could name the first triangle in between forwards and backwards, and then the right-hand triangle would have to have its letters or vertices to match. So get number 3. In number 3, this QS side is shared between 2 triangles, and this QR side and this TS side is also labeled as congruent. So far we have 2 sides shared between the 2 triangles. So we either need an included angle, which would be this angle here, to be congruent, and really they may be congruent, but we don't have enough information to say that they are. Now, if segment QR was parallel to TR to segment TS, then by alternate interior angles, we would have that this angle at Q and this angle at S were congruent, which would give us SAS pattern. And we don't have anything about RS being congruent to QT, so we can't use SSS. So really there's not enough information to be able to say whether those two triangles are congruent or not. They may be, but we can't come up with enough evidence to prove it. Let's look at number 4. Here we got a side labeled as congruent to that matching side over there. This angle BAC is labeled as congruent to this angle DCA. And then by the reflexive property of congruence, or by same side, AC is the same shared side between both triangles. That gives us another S part of the pattern. So between the two triangles, we actually have an SAS pattern. So these two triangles are congruent by SAS. If I name them correctly, let's say we're going to go BAC with the left-hand one. So triangle BAC is going to be congruent to triangle, starting out here, we got to go D. We went to the single marked angle. So D goes to C, which is a single marked angle, and then up to A. So B goes with D, B goes with D, A goes with C, A goes with C, and C goes with A. And that's the correct way to name those congruences. Okay, number 5. What additional information is needed to show triangle ABC is congruent to DEF by side angle side? So here we have a side, here we have an angle, we need this other side. Here we have a side, here we have an angle, we need this other side. So we have to somehow get proof or be told or find that segment AC is congruent to segment DF. Then that would give us the other S that we need to use the side angle side pattern. Let's look at number 6. Why can't SAS be used to show the triangles are congruent? So let's look at the pattern that we have here. So this A matches with E matches with H, which throws an A into the patterns. Segment EF is congruent to segment HJ. And segment DF is congruent to segment GJ. So let's look at the pattern that we have here. Here we have S, skip the angle, S, A pattern. Notice that this A is not the hinge in between the two S's. If ED was congruent, then we could see we would have an SAS pattern here. Over here, the same thing. We've got an S, S, A pattern with the other triangle also. So this isn't enough for us to say that the two triangles are congruent because we don't have an SAS pattern. Actually, this SSA pattern only works for right triangles. So it's, it's sort of a special case. But we don't have SAS. We've got an S, an A, and an S, but they're not in the SAS order. We would have to have A as being the hinge between the two sides. It's got to be the hinge. I should say hinge. Okay, a couple more. 7, 8, and then the rest of these will be to do for practice. Determine whether there's enough information given in each figure to prove the triangles are congruent. Use an SAS or SSS. If so, write the statement. If not, write not enough info. Let's look and see what we have. So we've got single mark with single mark. we've got angle U matching with Z, and we have US matching with ZX. So if we look at the patterns, we've got side, angle, side. So side, angle, side pattern works for this one. If I was to name the triangle, start with TSU. I'm just randomly starting with some order, but I need to be careful that I make the other triangle have matching order when I name its congruence. So T to S, I'm going from the 1 marked side to the 2 marked side along the side that isn't congruent, or isn't marked as congruent. So I'm going from the 1 marked side to the 2 marked side along the side that's not marked as congruent. I've got to go YX. And then from YX we go out to Z, and from TS we go out to U. So U matches with Z, yes. X matches with S. X and S would be those two. And X is after the two, between the 2 marked side and the unmarked side. S is between the 2 marked side and the unmarked side. And then angle Y and angle T. Angle Y is at the end of the 1 marked side to the non-marked side, and Y is along the non-marked side with the 1 marked side. So they're all in corresponding positions. So we have to be careful to name the congruents in the right order. Let's look at number 8. This double marked one goes with the double marked one. A goes with F, and AC matches with DA. So let's see what we have. We've got SAS pattern in the left-hand triangle, but in the right-hand triangle we actually have SSA. To be SAS, this D would have to be the hinge between the two S's, just like this A is the hinge there. Or if it was going the other way and we had EF, or EF as congruent, then we would have SAS. But we've got two different patterns. This one has an SAS pattern. This one actually has an SSA pattern. So we can't say that they're congruent, and we can't name any kind of a congruent statement since they're not congruent. Okay, here we have two right triangles. 90-degree angles are congruent to each other. That gives us an A. This single marked side or double marked side goes with the other double marked side. Triple marked side with a triple marked side. This gives us an SAS pattern between the two triangles. So these two triangles are congruent by SAS. Some geometries actually, because it's a right triangle, we call these legs. So CA is a leg and it's congruent to US, and ST is a leg and it's congruent to AB. So leg sometimes is used also in some geometries for two right triangles being congruent, and it only works for right triangles. It's really the same thing as the SAS pattern where the A is the right angle. So leg or SAS would be a reason we could say those two triangles are congruent. To name them correctly, let's go from S to T to U. So triangle STU is congruent to triangle. We went from S to T, from the right angle along the 2 marked side to T. So from the right angle along the 2 marked side to B is how we have to go with this one. So we went from S to T. To match the order, we have to go from A to B and then to C in the right-hand triangle. So we could name this congruence relationship STU congruent to ABC. As another example, let's say we wanted to do TSU. Triangle TSU, and name the congruence correctly with the other triangle. So from T to S, I'm going along the 2 marked side to the right angle. So B to A goes along the two marked sides of the right angle. So I've got to go BA. And then from B to A, we go to C. So T goes with B. Check up here. T goes with B. S goes with A. S goes with A. And U goes with C. U goes with C. So we got the correct corresponding positions. So either one of these would be a correct way of naming the congruence. And there are others with different orders. Okay, so these are the guided notes for the side, and side angle side congruence theorems, congruence shortcut theorems. Your assignment is to complete these pages for next class.